All right, let's work through some examples now. So the first thing we're going to do is we're going to look for vertical asymptotes. Okay, so if I'm looking for vertical asymptotes and I see this rational expression here, specific type of fractional expression, I'm most concerned about what's happening in the denominator. So in order to see that, I'm going to have to factor it. So denominator would factor into x minus 2x plus 1. I'm going to leave the numerator as is because it doesn't really factor over the reals nicely. Okay, so I take a look at this and then I note two things. I see that the denominator is 0 when x is 2 or x is negative 1. And I notice that the numerator here will not be 0 when x is 2 or x is negative 1. Okay, so that means right away my vertical asymptotes must be x equals 2 and x equals negative 1. So now technically the problem ends there. I've identified the vertical asymptotes. I want to go deeper here just to see how we deal with some of these limits. So what I'm going to do is I'm going to look at all the one-sided limits to show you how a good way to approach these. So let's say the limit as x approaches 2 from the left of x squared minus 2, and I'll use the factored form. It'll make it easier. Okay, so let's say I want to know exactly what's going on here. All right, they're vertical asymptotes, so somewhere there have to be infinite limits, but I don't know what they are and exactly where they are. All right, so the way to do this nicely is like this. We're going to take each quantity and see what happens when the limit is going to where it's prescribed to go to. In other words, if I take x squared minus 2 and I let x go to 2 from the left, x approaches 2 from the left. All right, so I can just try and plug in 2. 2 squared is 4 minus 2 is 2. So this thing is going to 2 as x approaches 2. It doesn't really matter left or right. Okay, so now what about x minus 2? X minus 2 as x approaches 2 from the left. So think about, there's 2, you're approaching it from the left, so things like 1.9 or so, 1.9, 1.99, 1.999. It is eventually going to go to 0 as you go towards 2, but is it positive or negative? So the idea is that I'm getting tiny fractions. 1.9 minus 2 would give me negative 0.1. 1.99 minus 2 would give me negative 0.01. So they're definitely going to 0, but they're going as negative numbers. So I make a little notation there that these numbers are going to 0, but negatively. X plus 1 as x approaches 2 is just going to go to 3. So the only place where I really need to be concerned about how it's going to that number is when we're around 0. Okay, so what do I get out of this? So the numerator is going to 2. The denominator is going to 0 because it'll multiply out to be 0. So that's a case of a type of infinity. But now I have to decide whether it's positive or negative, and for that I just do a bunch of sign counting, SIGN sign accounting. I've got a positive on top, a positive on bottom, and a negative on bottom. So I've got two positives and a negative. All these things together will give me negative infinity. It'll give me a negative number, and specifically it's going to negative infinity. All right. Just stay with me if you're not following. Let's go to 2 from the right. And we'll repeat the whole procedure. Okay, as we go to 2, the numerator still goes to 2. The x minus 2 in the denominator, now we're going to 2 from the right, so think like 2.1. 2.1 minus 2 2.01 minus 2. These are tiny numbers, but they're tiny positive numbers. So they're going to 0, but in a positive way. So there's my notation. Okay, x plus 1 still goes to 3. And overall, I still have a numerator that's going to a non-zero constant, and the denominator that's going to 0, which is going to take me to an infinity. But now I have a positive, and another positive. They're all positives. The end result is going to be positive. So I can either write positive or just leave it out because the assumption is positive. All right, let's take the limit as x approaches -1 from the left of x squared minus 2 over x minus 2, x plus 1. Let's do the same thing again. So now x is going to -1 from the left, but that only matters when we're creating a 0. All right, so x goes to -1, -1 squared is 1 minus 2, so the numerator goes to -1. X minus 2, when x goes to -1, goes to -3, -1 minus 2. X plus 1 goes to 0, but remember, we're approaching -1 from the left. So this would be like -1.1, say, as you're getting to -1 from the left. So I'm going to have a little bit of negative left over, because say -1.1 plus 1 leaves me a -0.1, and even -0.01 when I get that. It's always going to be a little negative. All right, so I have going to a constant on top, and the bottom is going to multiply out to be 0. So that's a type of infinity. But then I do my sign accounting. I've got a negative, a negative, and a negative. I've got 3 negatives, ends up giving me a negative. All right. Let's do the same thing now for -1 from the right. Okay, x squared minus 2 still goes off to -1. X minus 2 still goes off to -3. X plus 1 goes off to 0, but now again, there's -1. I'm approaching from the right. This would be like -0.9. Okay, -0.9 plus 1 is going to leave me a little positive, so this time it's positive. So here, I've got a constant on top and something that's going to multiply out to be 0 on the bottom. Tells me it's infinite. And I've got a negative, and a positive. The 2 negatives cancel. I have another positive. I get positive infinity. Okay, so that's how, if you do this kind of breakdown and look at every term and see what it's doing, that's how you can determine exactly what's happening. All right, let's take a look at another one here. Okay, g of t is t minus 1 over t squared plus 1. Okay, let's focus in on the denominator here. I would need the denominator to be 0. But t squared plus 1 is never 0. So this has no vertical asymptotes. That's fine, that can happen. All right, how about tan 2x? Okay, well, tan 2x is sine 2x over cosine 2x. So I would really need to know, when is cosine 2x equal to 0? All right. Well, cosine 2x equals 0 when x, all right, well, first let's start with 2x. So when is cosine equal to 0? Well, if you think a unit circle, that's at your pi over 2 and your 3 pi over 2. Basically any odd pi over 2, so 1 pi over 2, 3 pi over 2, and then 5 and 7 pi over 2, and all of that. So when 2x is n pi over 2, for n equals, and I could even go the other way, so I could go negative, so plus or minus 1, 3, 5, etc. Okay. Or another way I could write that is when 2x equals, so a nice way to just, instead of using odd n's and an n there, I could actually do 2n plus 1 pi over 2, and then just use n equals 0 plus or minus 1 plus or minus 2, etc. Just a way to come up with the odds. Any way is fine here. And so that would mean that if I divide then the 2 over, and x equals 2n plus 1 pi over 4 for n equals 0 plus or minus 1 plus or minus 2, etc. So that's where my vertical asymptotes would be, because for one thing, whenever cosine is 0, sine can't be 0, because sine squared plus cosine squared have to be 1. So whenever cosine is 0, sine is 1. So I know that I'm not going to get both of these things 0 at the same time.